So show that y is equals to log of 1 plus x minus 2x by 2 plus x, where x is greater than minus of 1 is an increasing function of x throughout its domain. So the value of x which is there, if you try to observe the value of x over here, minus of 1. So from here on, all the values are taken. So in this particular range, we have to see whether the given function is increasing, and we have to show that it is increasing in this particular range. So let us try to use the condition for increasing function. So let me write down what is given to us. Y is equals to log of 1 plus x minus 2x by 2 plus x. Right? That's the function that is given to us. And what we need to do is, once again, we have to check whether it is increasing or not. You have to find out the value of dy by dx. You have to differentiate this one. This particular value dy by dx should be greater than 0. It should be a positive value. For increasing function, it should be a positive value for this particular value of x. So we'll try to differentiate this one. Differentiate with respect to x. Differentiate with respect to x. So you'll be getting dy by dx is equals to log. So differentiation of log will be 1 by what is the value you're having? 1 plus x. So there is log differentiation. So once log is complete, then you have to move on for differentiation of 1 plus x. So what will be the differentiation of 1 plus x? Differentiation of 1, the constant will be 0 plus differentiation of x will be 1. So differentiation of log is complete, minus this 2x by 2 plus x. So this is in the form of u by v. So this will be acting as your u value, and this will be acting as your v value, u by v. So it is d by dx of u by v, the quotient rule. It is v into u dash minus u into v dash divided by v square. So let us try to use this one. V value is 2 plus x. V into, it is u dash. U dash means differentiation of this 2x, 2 as it is, differentiation of x with respect to x will be 1. So it is v into u dash is complete, minus u. U is 2x into v dash. V dash means you have to differentiate this one. To the constant differentiation will be 0 plus x. So differentiation of x will be 1. So differentiation is complete. Whole divided by, you're having, it is whole divided by v square. So v value is 2 plus x and it is squared. Now let us further simplify this one. This will be equals to 0 plus 1 will be 1 itself. It is 1 by 1 plus x minus O here. You're having 2 O here. You try to multiply this 2 with this. Let me read it. This is 2 into 1 it is. So 2 into 1 will give you 2. So this is 2. So this 2 has to be multiplied by this value. So 2 multiplied by 2 will give you 4. Only 4 will get, you'll be having plus. Again, multiply this 2 with x, you'll be getting 2x. This is done. Next value that you have is minus 2x. Minus 2x is multiplied by 1. So you'll be getting the value as minus of 2x. Whole divided by the denominator value. The denominator value will be 2 plus x. It is 2 plus x whole square. Now further, if you try to observe over here, this plus 2x and minus of 2x will cancel out, and in the numerator you just have the value as 4, right? 1 by 1 plus x minus, how much is left out over here? It is only 4 by, it is 2 plus x whole square. So derivative has been obtained, but this derivative value that we have obtained over here should be what? Should be greater than 0. But how to check whether it is greater than 0 or not? For that, we'll try to take the LCM, because there are two terms over here. It's better you take the LCM. LCM will just be the product. 1 plus x into 2 plus x whole square. So now what has to be done, you need to just cross multiply this one. This value will go here multiplied by 1. This 1 plus x value will go here multiplied by 4. So we'll be getting 2 plus x whole square. And this minus 4 is multiplied by 1 plus x. Let us further simplify this expression. If you try to simplify this expression over here, we need to expand this one. This is in the form of a plus b whole square. So use the formula of a plus b whole square to be equals to a square plus 2ab plus b square. So your value of a will be 2 over here and your value of b will be x. So let us just try to plug in over here. A square will be 2 square plus 2 times of a is 2 into b. B value is x plus b square. B square will be x square. Then minus, you multiply this 4 inside, 4 times of 1 will be 4 and minus into plus will be minus 4 times of x, it is 4x whole divided by, denominator will be as it is 1 plus x into 2 plus x whole square. Or further, if you try to simplify this one, 2 square will be 4 plus 2 times of 2 will be 4, so 4x plus x square, and this minus 4 and minus 4x will remain as it is, whole divided by the denominator as it is 1 plus x into 2 plus x whole square. But further, if you try to observe over here, this plus 4 and minus 4 will get cancelled, and also this plus 4x and minus 4x will cancel out. You are just left out with x square by 1 plus x into 2 plus x whole square. Now I have to show this value which is there should be a positive value for increasing function. But the moment you try to observe this, square terms will always be positive. So do you agree that x square will be positive only? And 2 plus x which whole square which is there, that will also be positive. The only term that is left out over here is 1 by 1 plus x. Now the question is, now whether this is positive or not, depends upon this term. If this term is positive, then dy by dx will become positive. Suppose if this term is negative, then dy by dx will be negative because the square term will make this as positive. So do you agree with this one? Now we have to check whether this value is positive or not. We have to just show that this value is positive. This value is positive. We have shown that the function is increasing. To show that one, we have to check what is the value of x given x is greater than minus 1, right? If you try to see on the number line, this is 0 and this is minus 1, then you're having 1 over here, you're having 2 and so on. Greater than 1 means, is this included? This is not included. That means the values will start from 0 onwards, right? So the minimum value that x can take over here is 0. So if I take, if x is equals to 0, then what will be getting? 1 by 1 plus x will become what? 1 by 1 plus 0. Is it 1? Is this greater than 0? For the first value that you are starting with, x is equals to 0 only because x is greater than 1. And if you are taking all the values for all values of x greater than this one, if x is equals to 1, in that case also, this value will be greater than 0. And subsequently for all values of x, this value that you are having 1 plus x will be greater than 0. So now this has become greater than 0. This value which is there is greater than 0. This complete value which is there is greater than 0. And the product of two positive values will be positive value itself. So hence we can conclude that hence 1 by 1 plus x will be greater than 0 provided the value of x is greater than minus of 1. Hence we can say that dy by dx, the first value is a positive value, into the positive value will be what? Will be a positive value itself. If it is a positive value, we can say that dy by dx is what? Greater than 0. So hence, we have got y as an increasing function. Is increasing, right? Y is increasing. That was the question, right? Is an increasing function of x throughout the domain, this domain, x greater than minus of 1. So y is an increasing function.